So in this question, aqueous solution contain 4 grams of sodium hydroxide in 25 cm cube. We want to find the pH of a solution. To get the pH, first we should know the concentration of hydroxide ion. Using the concentration of hydroxide ion, we'll find the concentration of hydrogen ion by using Kw. And from hydrogen ion, we can find the pH. pH is equals to minus log of hydrogen ion concentration. So first we'll find the moles, mass in gram. So 1 divided by 10, which is 0.1 mole. Then we'll find the concentration. Concentration is moles over volume. So 0.1 divided by volume is 25 cm cube or 0.25. So 0.1 divided by 0.25. So 0.1 divided by 0.25, that's equal to 0.4. So the concentration is 0.4. And sodium hydroxide is a strong alkali, so it dissociates completely into sodium ion and hydroxide ion. So what is the concentration of sodium hydroxide ion? The same concentration will be there for hydroxide. And then Kw is a product of hydrogen ion and hydroxide ion concentration. So that will be same, 1 exponent 14 is there. That is the concentration of hydrogen we'll find, and hydroxide we know that is 0.4. 0.4 is multiplied, other side will be divided. So it will be 1 into 10 to the power minus 14 divided by 0.4. So this will give hydrogen ion concentration. And then we will use the formula pH is equals to minus log of hydrogen ion concentration. So the pH equals minus log of hydrogen ion concentration. We substitute. This will give us 13.6, the pH of this solution. In question 10, a solution containing HCN and KCN is a buffer. When a small amount of acid is added, the solution acts as a buffer because. So why this solution is acting like a buffer? Buffer solution means solution which resists the change in pH. So in HCN, basically KCN is a salt. So when we have KCN, it will dissociate into K plus and Cn minus. Because when salt dissolve, does not exist as a molecule, it will be an ion. But HCN, it is an acid, a weak acid, it dissociates into H plus and Cn minus. And second possibility, because it's a weak acid, so weak acid, there's an equilibrium or a balance between ions and molecule. But for weak acid, there will be more molecules and less ions will be there. Now in the question, we add a small quantity of acid. So we add H plus ion. So as a result, when we add H plus ion, the H plus ion which is added will react with Cn and it will form HCN. So very small proportion of addition of H plus does not cause any change in pH, because like if I add one molecule, we have a reservoir, like we have a reservoir of cyanide ion. So even this cyanide can react, this also can react with H which we are adding, and it produce HCN molecule. So hydrogen ions in the acid combine with cyanide ion to make HCN. So A is the right answer. Is it clear? In question 11, when 0.1 mole of hydrogen and 0.1 mole of iodine were allowed to react with each other, 30% of hydrogen was found to be converted at equilibrium. The number of the moles of a gas present at equilibrium. So H2I2 gives HI, 2HI. So 0.1 mole is there in the beginning. This is also 0.1 and this will be 0. Because in the beginning, we'll always have reactant, no product. Then, or sometimes some question they give you a product, but most of the question, in the beginning, you don't have any product. 30% of hydrogen has been converted. So if 30% is converted, so remaining will be left. So I will take a 30% of 0.1 and subtract. So 31% of this will be 0.03. And 0.1 minus 0.03, we don't write how many converted, we write how many left. So 0.07 will be left. And because the ratio is 1:1, so same number will react, so same number will be left. And produce here, because if 0.03 moles are converted, so the ratio is 1:2, like one molecule of or 1 mole of hydrogen give 2 moles of hydrogen. So if 0.03 are converted, so how many moles they will produce? They will produce 0.06. So D will be the right answer. So it is basically how many moles of reactants are left and how many moles of a product are there at equilibrium that we use for our calculation. Because this one 30% is used, 30% is used, and here 30% produce 2 moles, like twice. So it will be, that's why it is 0.06. Which compound shows both geometrical, to show a geometrical isomer, there should be 2 different groups attached to carbon. And to be optical isomer, there should be 4 different type of groups are attached to carbon. So when we check the options, this cannot be geometrical. Why? Because carbon is bonded with 2 methyl groups, so no possibility of geometrical isomer. This can have geometrical. This cannot have geometrical because CH3 bracket 2, so 2. And this can also have geometrical. Then we have to check optical. So B and D can have geometrical, but the second part we have to check optical. This cannot be a chiral carbon. This carbon can be a chiral because CH is there, H is there, CH3 and CH2. So there is a chiral carbon. And this, you don't find any chiral carbon. So that's why B is the right answer. Which set of reagent is not suitable for the steps indicate? So which is not suitable? So when we check, we have ketone, we convert into nitrile. So step 1, HCN plus KCN, that is true because we should use step 1 is correct. Step 2, hot ethanolic potassium hydroxide. So if we use potassium hydroxide KOH, there is an elimination reaction occur. So here what will happen when elimination reaction, because this is hot ethanolic potassium hydroxide. Basically, because it is a nitrile group, so when it is a nitrile group, for nitrile group, when we do acid hydrolysis or the base hydrolysis, they produce carboxylic acid. This is only possible if we have, like example, if we were having like halogen alkane, this is related to AS. If we were having an halogen alkane and we use ethanolic or alcoholic potassium hydroxide, elimination reaction occur. So this reaction is only possible, or possibility is there when it is converted into, to convert a pure halogen alkane into alkene, but not this one. So that's why step 2 is not correct. Step 3, warm sulfuric acid, aqueous sulfuric acid. So again, you can see like elimination reaction will occur if we use sulfuric acid. So elimination reaction will occur, and then carboxylic acid. If we, so it will produce an ester. Carboxylic acid react with alcohol, so produce an ester. That is also correct. But why B is incorrect? B is only valid when we were having a halogen alkane. So elimination reaction occurred for that halogen alkane which produced alkene. Question 14, the molecule shown has three functional groups which are labeled X, Y, and Z. Which of the following groups can undergo a nucleophilic attack? So nucleophilic attack here refers to, because nucleophile means like nucleus loving or a positive side, attracted towards the positive side. So we have to check. Look, it is easy to recognize here. Y cannot undergo a nucleophilic attack because Y is carbon-carbon double bond. If there is a carbon-carbon double bond, always electrophile will be attracted towards carbon-carbon double bond. So any option with Y is not correct. Now what about Z? Because you can see here, this carbon will be positive, partial positive, bromine negative. And here also oxygen negative and carbon positive. So any nucleophile can attack on this carbon or any nucleophile can attack on this carbon. So one is a halogen alkane group. So in halogen alkane, there's a nucleophilic substitution reaction. And another one is a carbonyl group. It can be, it is a ketone, but even if it was an aldehyde, it will undergo nucleophilic addition reaction. So here the nucleophilic addition reaction will occur, and here the nucleophilic substitution reaction. So X and Z can undergo a nucleophilic reactions. Question 15. What is the formula of a pale yellow precipitate formed when propanone react with iodine in the presence of sodium hydroxide? So it will, the precipitate are basically idopropane. Sorry, idomethane are there. The precipitate of idomethane are produced. So 15, or triidomethane basically. So 15, it is like 3 iodine molecules are there and 1 hydrogen, triidomethane, and this will give a yellow solid or yellow PPT. Butanone can be distinguished from butanoic acid by, if I add phthalate or benedict solution, aldehyde and carboxylic acid, sorry, ketone, then carboxylic acid cannot be oxidized. I cannot oxidize ketone, neither carboxylic acid. Toluene reagent also, aldehyde can be oxidized, but not ketone or carbo. 2,4-dinitrophenyl hydrogen, that is a test to identify the aldehyde or ketone group. So C is the right answer. Acidified potassium dichromate, aldehyde, ketone, and carboxylic acid both cannot be oxidized, so it does not show a color change. Question 17, which could be used to make CH3 C double bonded? So basically, amide. We want to make an amide, so CH3 C double bonded with O, NH, and CH3. So if I mix ester with ammonia, so using ester with ammonia, actually there is no reaction. If I mix here, this is already amide. So like if I have CH3, 3 double bonded with O, NH, and this is CH3, then there is NH. Partial positive, negative. This is partial positive. Basically, in this case, hydrogen will be partial positive. And here also partial positive and partial negative on. So you don't find a reaction here. It is already like a amine group is there, so negative, the negative part always replaces the negative. So they can displace each other, but it does not lead to a product. Then this is the ester salt. Again, ester salt does not. But when we have ethyl chloride, like example, we have CH3, C double bonded with O and Cl, and the CH3 and NH, NH. Partial negative, positive, partial negative, partial. So the whole negative part will take position of chlorine. As a result, it will produce CH3, C double bonded with O, NH, and then CH3 plus Mitri fumes of HCl. So you can see the same product is by reaction of ethyl chloride with alkylamine. In question 18, which reaction may be used to make carboxylic acid in a single step? Hydrolysis of the ester. Yeah, when we do hydrolysis of the ester with hydrochloric acid, so it will produce, because if we do hydrolysis, it will produce carboxylic acid plus alcohol. And because it is with hydrochloric acid, so already the solution, there are more H plus ions. So as more H plus ions are there, so the carboxylic acid does not further react with alcohol to form ester back again. Then hydrolysis of the ester with sodium, that does not work. Why? Why this will not work with sodium hydroxide? Because when we hydrolyze ester, it produces acid and alcohol, and that acid can react with sodium hydroxide. That's why it does not work. Acidified potassium manganate, that is for alkene, and acyl chloride with ammonia, so that produce amide. And then, so it does not produce even an acid. That's why A is the right answer. So B is like not correct, because carboxylic acid won't be there as sodium hydroxide reacts. C will produce diol if alkenes are there, and D will produce amide when acyl chloride react with primary this alkylamine. The mass spectrum of ethyl chloride would not be expected to have a peak. So which peak? We have CH3, C double bonded with O, and Cl. Look, this can be 12 plus 3, 15. This will be 12 plus 16, so 28. And this chlorine can be 35 or 37, but not 30. 35.5 is the average mass of the chlorine isotope. But if we have one atom of a chlorine, it might be 35, it might be 37. So we may get a peak at 37, that's maybe if we get chlorine. We may get a peak at 43, because 15 plus 28, 43. We may get a peak at 78, the total mass. But we will never get a peak at 35.5, because one chlorine atom is not having a mass of 35.5. It is the average mass of the two chlorine atoms. Is it clear, this one? Then in question 20, ketone, a ketone would not be expected to have a peak at mass to charge of 57. So we don't expect to have a peak at 57. So this will be 15, 15 plus 12, 14, 29, 29 plus 28. So it will be 29 plus 28, yeah, 57. So it will get P. Here, this is when I draw the structure CH3, this H, and C double bonded with O and CH3. So when we work out the peak, it might be 15, and this all together is there because it is attached as a branch. So 12, 24. plus 4 to 28. So we'll get a peak at 43, and 28 plus 28. So we'll get 56 will be there, and 56 plus 15. So it will be 71. No, yeah, 56 plus 15, 71. So basically, when we are finding a peak, we will read from left to right and right to left. So we'll get a peak at 15, and 15 plus 28. So we'll get a peak at 43. If I'm reading from my left to right, then we'll get a peak at so 56, like 15 plus 28. So 43, 43 plus 28. So it will be 71, and 71 plus 15. So we'll get a peak at 84, 86, sorry. And then from right to left, 15 will be there, 43 will be there, 71 will be there, and 86. So we don't get a peak at 57. So B will be the right answer. For C, where like this is 15, 14, 28. So 15 for that will be 57. This will be 15, 15. Like here also 15, 14, and 28. So there will be a peak when we read from right to left. So this will get peak, this will, but B cannot give the peak at 57.